All right, hello everybody. Doing a video lesson today for section 3.1 and 3.2. And so we're going to go ahead and get started. I'm having a little bit of some issues with the platform that I normally use for this, so it may be a little bit clunky today. I'll have it back up and running by Thursday. So hopefully you printed out these notes and we'll just go ahead and get started on chapter 3. Okay, so a quadratic function in standard form is given by, so we have y equals ax squared plus bx plus c. So plus c, where a, b, and c are numbers with a not equal to 0. Okay, so let's go ahead and look at some examples of different quadratic equations. So, and talk about these coefficients a, b, and c. They're going to be important because they affect the shape of the graph and things like that. So let's look at our first one. 1 minus 7x squared minus 12x. No matter how, what the order is, a is the coefficient on the x squared. So in this problem, a equals minus 7. B is always the coefficient on the x, so that's minus 12. You have to include the minus. And then c is the constant term, which is the number out by itself. All right. So for number 2, a would be minus 8 and b would be 3. There is no constant term, so we can think of that as adding a plus 0. So c is 0. In number 3, we have, let's see. Like I said, this is not working that great. Number 3, I have what is almost like a quadratic function, but I have that denominator. What I can do, though, is go ahead and divide every term by 2. So what rewritten, this is 2x squared minus 1/2 x plus 5. A is 2, b is minus 1/2, and c is 5. Now in this number 4, when you can't have the variable in the denominator. Okay, in the problem 3, I had a denominator, but it was just a number. In problem 4, this does not fit the form, so this is not quadratic. I'm not sure if y'all can hear my cat meowing. She's very desperate for somebody to give her more food. Okay, let's ignore that. All right, so, okay, so number 3 says the graph of quadratic function takes the shape of a parabola, P-A-R-A-B-O-L-A, and the examples below. So I have 2 examples of a parabola. It either looks like a U or an upside down U. And we're going to talk about the x-intercepts, the y-intercepts, and then the vertex. The vertex is the high point or the low point. So I have a vertex right here, and then I also have a vertex right there. So the high point or the low point of the graph. The term ax squared is called the quadratic term. It's the term that has the x squared. If a is greater than 0, the parabola opens up. And if a is less than 0, the parabola opens down. So in other words, the coefficient on the x squared determines whether the parabola opens up or down. The term bx is called the linear, L-I-N-E-A-R, linear term. And the number c is called a constant term. Linear term, constant term. And let's see. Also, c has another sort of interpretation, C represents the y-intercept. So if I know the number C, I know where the graph crosses the y-axis. It's also, we're going to see in a little bit later, it's also called the initial value. And the reason it's the initial value is because the way you find the y-intercept is you let x equal 0. So the number C in a particular quadratic equation is the number you would get if you let x equal 0, and it gives you the y-intercept. All right, so we're going to look at some examples of graphs and then talk about the problem. Says state whether the values of A and C are positive, negative, and 0. So remembering, so for the first one, so remembering that A tells whether the parabola opens up or down. In this first example, the parabola opens down, so that means A is negative. C is the y-intercept. Okay, so in the first problem, since C is below the x-axis, the y-intercept is below the x-axis, C is negative. Okay, let's look at the second one. And the parabola opens up, so the parabola opens up means A is greater than 0. The y-intercept is right here below the x-axis, so that would be a negative number, so C is less than 0. On this third example, the parabola opens up, so A is greater than 0, and my y-intercept is right there, which would be a positive number, so C is greater than 0. Right now I don't have the equation, I'm just using the interpretation. And then in this last example, the parabola opens up, so that means A is greater than 0. I don't see the y-intercept on the graph. It hasn't happened yet, but I know if I would keep following this graph, eventually it would cross the y-axis, but above 0. So C is positive. Okay, so next, express the quadratic equation in standard form. Now, instead of finding A and looking at graphs, we're going to expand this out. And so what we're going to do is standard form means that everything is distributed, multiplied, combined like terms. The x squared term comes first, the x term comes second, and the constant term comes third. Okay, and when I say x squared, I mean whatever the input variable is. So in our first problem, it's a t squared. So I'm going to distribute and combine like terms. So I have t squared plus t. There are no like terms to combine. So that's standard form. A is the coefficient on the x squared, or in this case, t squared. B is the coefficient of the t to the 1, so B is 1. And C, there's no number C written, so C is 0. Okay, for number 7, g of x, and I'm going to have to multiply this out. This is equal to x minus 2 times x minus 2. So g of x is x squared, and then I have minus 2x, which would give me minus 4x plus 4. So A is the coefficient on the x squared, B is the coefficient on the x term, and C is the constant. Okay, now you have to include the negative. Don't say B is 4 because it's not. It's negative 4, and it makes a difference. Okay, everybody pause the video, and I want you to do 8 and 9. And then come back when you're done. Okay, so I'm assuming you're done. So we have R of W equals W squared plus 4W plus 3W plus 12. So R of W is w squared plus 7w plus 12. So to put a quadratic equation in standard form, you have to multiply everything out and combine like terms. A is 1, B is 7, C is 12. Okay, let's do the other. Erase this just for some space. And then S is, now I'm going to do order of operations. Exponents go first. So 2 times, and then I need t plus 2 times t plus 2, and then I'm going to subtract 1. So 2 times, and then if I multiply that all out, that's going to be t squared plus 4t plus 4 minus 1. Now I'm going to distribute the 2, so exponents, parentheses, exponents, multiplication. So 2t squared plus 8t plus 8 minus 1. And then now combine like terms. 2t squared plus 8t plus 7. So A is 2, B is 8, plus 7, and C is 7. Okay. Now let's look at an example. Let h of t equals minus 16t squared plus 32t plus 128, where h is the height of a ball thrown at time t. What is the practical meaning of the value of 128? All right, so you have you throw up a ball, and then eventually it comes back down. The height is given according to this formula. So the value of 128, notice that is our value of C. C is 128. Okay, so back to the beginning, we said the value of C was the y-intercept, or it's also known as the initial value, and in this case, the value is height. So this means this is the height of the ball when t equals 0. So that is the height of the ball wherever it was thrown. And it's 128, so obviously it's not on the ground. Okay, so what is the practical meaning? Is that the ball is thrown from 128. It doesn't say units, so let's go ahead and put it in feet. Okay, so someone is standing 128 feet above the ground, and that's why they threw the ball. So that constant term there is the initial value. All right, the next part, how high is the ball after 2 seconds? So that's a time value, so t equals 2. So this is just function evaluation. H of 2, and then we'll go ahead and sub that in, and we'll say, let's see, negative 16 times 2 squared plus 32 times 2 plus 128. And, oh, look, that's 128. So it's 128 feet. Now you might think, how's that possible if it started at 128? Well, what happens to a ball? You throw it, it goes up, and then it's going to come back down.